Hi, everyone, and welcome to another episode of the Community Office Hours here for Modern and OpenRewrite. As I want to say, as always, I'm your host, Tim Beek, and with me here is Sam Snyder. But
Well,
truthfully, I've been out for 5 weeks, so good to be back.
you've gone on quite the world tour. You were just telling me Mexico, United States, only briefly back in your home country of the Netherlands.
Yep, I was back for 36 hours and out the door again to Paris for Devox France. So, but now I'm back for 3 whole weeks, so that should be good. But yeah, good to be here and hosting and be able to see you again and yeah, tell you all the things that are new in OpenRewrite this week. So as always, I'll run through a quick list of things that are new and maybe interesting for our viewers, and then beyond that, we're going to introduce Shannon. Shannon is an open source contributor, and we'll talk about all the things he does for OpenRewrite and yeah, how that might inspire you to do something similar. So with that, I'm going to pull up my typical list of tabs and do a quick run through. Now, most importantly, I think the news for this week is that we did a new release. So typically I'm the one to shepherd these through, and we had Kevin do that while I was out. But there's been a lot to catch up on, and all of that is now, as of today, bundled into a new 2.10.0 release of the rewrite recipe bomb with matching releases for OpenRewrite and the Maven and Gradle plugins. So if you want to know all that has been contributed over the past couple of weeks, go check that out. There's a lot of good stuff in there. In particular, the team at IBM has been very productive on the Rewrite Migrate Java project, where you can just see there's a lot of new recipes that are going to help folks that are still on older versions of Java and want to adopt the newer releases in a more automated fashion. So yeah, really pleased with that collaboration, and you can see that there's a lot of new contributors in here as well. So be sure to check that out. And then, yeah, as always, chime into the Slack if you have any questions or suggestions on what we could be doing next. So then, looking ahead, I can't be home for too long. As I said, I'm going to be here for 3 weeks, and then it's off to Germany. So that's luckily that's a 2-3 hour drive, and I'm going to be there with a workshop on transforming code with OpenRewrite and Refaster, together with a friend of mine, Beek driver, who you also have seen on this podcast, where we are going to look into various ways to develop recipes and automate code changes for your own projects. And that's not enough, because on Wednesday, I'm doing a new talk as well, where we're going to take you through just a selection of things that you might want to automate, typically using recipes across your microservice architectural landscape. So really excited about that one as well. So yeah, if you are going to be in Germany, be sure to check those out. And if you don't yet have tickets, I have just a couple of tickets to give away. So reach me on email or Slack or whatever platform you fancy, and get in touch, and I'll get you a discount code for 100% to get you into that event. And then 2 weeks after that, I'm going to be in Barcelona together with Jonathan Schneider, where we're going to present on how you can use generated AI to help you refactor your source code for OpenRewrite. We did a preview of this talk in the Dev Nexus in Atlanta, and we're going to do a slightly refined, revisited version in Barcelona. So be sure to check that out. And we'll also be there with a booth. So we have a few more colleagues coming in, so you can meet all of the team and just talk to us anything that you might want to be doing in terms of modernization there. And then one conference I won't be at is UberConf. This has come up in July 16th, where we're also going to present on a full-day workshop on the fundamentals of migration engineering with OpenRewrite. So be sure to check that out as well if that's near you. I'm not sure if this is one of those traveling conferences. I think we have one of those coming up as well. But at the very
They're
least,
also
it's going to
giving
be
the keynote presentation at this one, or one of the keynote presentations.
Perfect. That should be in here as well. So yeah, but be sure to have a look there. It's probably on the Wednesday. And
I actually saw it on the
see
bottom before you expanded. Oh yeah, there's that one. So there's your 2 workshops plus a keynote.
Perfect. So yeah, enough content to keep you interested in all things OpenRewrite. Because we were recently at DevNexus, as I said, in Atlanta, and there we also did a workshop and a presentation. But we also found that all our various friends have been mentioning OpenRewrite in their various presentations, and we got a shout out in the keynote as well. Such that we had quite some traffic at the booth, which was really fun, where folks come up to you that's telling us that we're the talk of the town, and that they want to learn more about how they can use both OpenRewrite and Moderne to help with their type of automations that they're looking to do. And it's I don't know, I always like it to just discuss with folks, and then you learn surprising things, like they still have Spring Boot 1 or Spring Boot 2 that they need to move away from. And of course, everyone who's tuning into this podcast probably knows that we can really help you there in automating that change for you. Another announcement we made at DevNexus is that we've joined the Common House Foundation. And the Common House Foundation is, I should have a tab here. That is this one, where this is for us really underwriting that we are committed to our open source license. So you've probably over the past couple of years noticed that there are some projects who start out open source and then find out that that model doesn't work well for them, and then they switch to a more restrictive license. We are going in the opposite direction. We are giving our trademark to this foundation, underwriting that we are committed to our Apache software license, such that if there ever comes a moment that we can no longer sponsor the project, that the trademark is then safe with this foundation. So they can do the succession planning there, and they can gather financials. It's all things, it's like an insurance policy that we hope to never need or use, but it is committing ourselves to this license that we currently have. So
right. So if we tried to switch to a commercial or more restrictive license, and it would be us who would have to fork OpenRewrite and assume a new name, as the Codehouse or Common House Foundation would own the OpenRewrite trademark. And so, yeah.
Yep. So absolutely. So all the things that you've might been seeing with Open Tofu succeeding Terraform, all of those things that we are well capable of automating for you. We're not going to force you to go through for OpenRewrite. So know that. So that was a nice thing to come out of what we announced at DevNexus. And then finally, with the presentation we gave there on that Jonathan and Justine gave, that one got a full room on just with folks interested in how we at Moderne use AI in the services that we offer. Because we saw there's a lot of interest in the topic, but there's maybe also a bit of disillusion in what it actually delivers when you start to run this at scale. And for that, we have a matching blog to tell you exactly how we're approaching the topic of AI at Moderne, and how we see that complementary to what we already do. Because if you have a couple million lines of code, we don't expect us to let AI loose on all of that. But we have some use cases where we think it's a nice complement to the work that we're doing, that you will see the benefits of if you use the Moderne platform. So have a read there. Go watch the talk as well if you want. There's a new option indeed coming out for UberConf to catch that one, or at Spring.io. So if you haven't seen it yet, know that there's various ways to get that information for you. And so then that's it, mostly for catching you up on events that are recent. I was at DevX France, but none of that was unfortunately recorded. But we had a lot of fun introducing folks to OpenRewrite and Moderne and what we can do there, and a workshop to get people really up and running, which we'll, of course, repeat at upcoming conferences as well. So then, in terms of other news, we have a collaboration, as you might know from the call that we did with Justine with Mila. And then the head of Mila, Joshua Ben-Chio, he has been named one of the 100 most influential people of 2024 by Time Magazine. So that really underwrites that we are in the right place there to have this collaboration, to see what we can do to help you modernize code in a way that is using the very latest of technology that is out there right now. So that's quite neat. Also very cool is that you can listen to an hour-long podcast hosted by Adam Jim on how OpenRewrite came about, where Jonathan Schneider goes into detail on all that went into creating OpenRewrite and all the bits about his background leading up to that and how all of that came together to where we stand now. So if you're interested in that, you can listen to that. It's on Spotify and other platforms as well. If you go to airhacks.fm, you can get the direct link there. So be sure to check that out. And then if you're into the video format, which if you're watching this platform, you probably are, we also have a new video to help you find sensitive API endpoints, where our colleague Mike will guide you through a recipe that we wrote recently, where you can use the platform to, across your entire organization, find endpoints that might expose personally identifiable information. So that is information that you might not be allowed to share as easily, that you want to be well aware of. And this is a recipe that helps you get there. And this is something that is using a slightly more fuzzy matching, such that you're able to find more and more use cases, even if you're giving it a vague description of what you need. So have a look at that one, and it's out now on YouTube, and we'll share the link as well after the call. And then finally, I already told you about the Common House Foundation, and as one of the presentations that was given at DevNexus, the folks at Netflix gave a shout out to OpenRewrite and Moderne, where they're using our technology to help modernize their code. And then they had one slide specifically, because you see they have some 80 slides and all the things they helped build to build up the infrastructure to do these types of modernization. And then finally, there was one slide that says that if you are not Netflix, and statistically speaking, a lot of folks are not working at Netflix, and you want to use all these same automations in a convenient package, then there is the Moderne platform to get all those same automations then in just a convenient wrapper that you can directly use rather than have to build yourself. So that's it in terms of tabs I wanted to take you through so far. And with that, I think we can move on to the main topic of today. And for that, I'm going to introduce you to Shannon Pamperl. And I'm going to pull him up, and then you can see him here as well. So Shannon, hi, welcome, and thanks for joining.
Yeah, nice to join you guys too.
Yeah, good to have you here. So for this, everyone, this is Shannon Pamperl. He's one of the oldest and most prolific contributors to OpenRewrite. You may already know him from him answering your questions in the open source community Slack. But if you don't, and you have ever run a Groovy or Gradle refactoring recipe, and it actually worked and did what it was supposed to do, there's a good chance that fixes contributed by Shannon are why it actually worked. So it's been a real pleasure to have you as one of our as our contributors, basically right from the very beginning. You started showing up and asking intelligent and interesting questions about apparently unrelated details of the parsers or how the LSTs were put together. And it's like, what is this guy building towards? You know, it's pretty frequent that you get a question of like, this doesn't work. Why? It's less common that you get of like, why is this thing implemented exactly how it is? So that's made me curious to learn, like, what got you involved in OpenRewrite initially?
So that's actually kind of a funny thing there. Your CIO is a former colleague of mine, John Schneider.
Yep.
He used to work at Shelter with us, and in typical John fashion, he likes building really interesting things.
For sure.
So one day I just kind of get a message out of the blue from him and saying, "Hey, I've got a new project that I think's up your alley." And he shared the, initial workings of OpenRewrite. And I'm like, that looks cool.
Yeah.
And from there, it was just kind of all right, let's dive head first and figure out what this thing's about and what it can do.
Right on, man. Yeah. So, what were some of the problems that you have used Open Rewrite or recipes or the Moderne platform to solve?
Yeah. So for me, like, I'm a Gradle user, right? So when I stepped into that platform, that area of OpenRewrite, my largest thing was like, okay, what can I do with Gradle scripts? Like, that's the first thing.
Mhm.
As you remember back when there wasn't a lot of Gradle support at all. I don't even remember if there was a parser originally.
I think you probably started looking at the project before we had begun Rewrite Groovy or Rewrite Gradle.
Yeah. So then, like, you introduced that shim, and then from there, it was just kind of taking it and saying, okay, well, let's do some fun stuff with Gradle.
Mhm.
We can obviously do some fun stuff with Java. Like, the sky's the limit here. So starting out with, hey, let's.
It's true. Shannon is a Gradle expert. I mean, I owned a large Gradle build at Tableau for many years, and then worked at Gradle for a while. And Shannon will still occasionally comment on some Gradle build logic I've put together or a plugin, and provide useful pointers and tips that I wasn't aware of, or guide me towards a best practice I was neglecting.
Yeah. Yeah, it was just a fun part of like, hey, I want to manipulate dependencies.
Yeah.
Well,
What do I have to
traverse
do to
the
do that?
LST model. Poof. Now you can do basic things, change the group, the artifact, add a classifier, remove the whole dependency.
Yeah,
Then
yeah,
it was
yeah.
like, okay, what more can we do?
Yeah.
Change dependency.
Mhm.
One of the big things I remember is like that stands out that like was like, yes, this finally works. Was when
Yeah.
we did the dependency version dynamic lookups
Yeah.
and seeing that work in the SAS as well.
Yeah.
It was just like, yeah, we've made it. This is
Yeah, it's a basic thing, but it's pretty magical, since even in one moderately sized repository, you could easily have hundreds or 1,000 dependency declarations. And even if you're doing absolutely everything right as a software developer, you have to keep on top of your software supply chain. Things constantly need to be updated and patched, and some of these little rote operations of fiddling with dependency versions, it's just a drag to have to do it yourself. And as professional automators, right, that's what we all do, is automate stuff. It's
uh-huh.
grinds my gears a little bit not to be able to automate something tedious that I have to do on a repetitive basis. So yeah, I totally hear you there.
Yeah,
So
for sure.
in my position, working with a lot of customer success, and of course on the core refactoring framework, I end up teaching a lot of people how to write recipes, how to interact with the framework, and answering
Mhm.
their various questions. So I was curious about your experience navigating that learning curve, right? Because there is a learning curve to start
Yeah.
thinking in LSTs, to think about
Mhm.
recipes in a productive way, to navigate the nuances here. What are
Mhm.
some of the challenges you encountered in learning how to use and author with Open Rewrite, and how did you surmount those challenges?
Yeah, I think the biggest one really is getting a grasp on the data model itself.
Yeah.
As technologists, like the way we organize data is kind
Hmm.
of that first boundary of how we then work with that data.
Yeah.
Um, you know, whether it's the JLST type representing
Hmm.
Java languages and the higher level compiler types, a compilation unit, a class definition, et cetera, et cetera.
Hmm.
Like those are kind of the foundational parts of how then you then can
Hmm.
really rapidly traverse that densely connected graph.
Hmm.
And once you kind of have a handle on that data model, it's then using a typical visitor pattern. You know, what do I want to find?
Were you already familiar with the visitor pattern when you started working with OpenRewrite? Because it's one of the common data access patterns, but some engineers can go a whole career without using that, and some use it all the time. So just curious, were you already hip to visitors?
A little bit. So I've used the Java visitor for files pretty regularly. And then I had a little tiny exposure from John to the ASM visitor. Ironically enough, when he was at Shelter, he built something very similar to OpenRewrite's Java find types.
Right.
Except his source input at that time was the binary jars, and using
Right,
ASM
of course,
to populate that into a graph database, because at the time he was also interested in graph databases.
Right.
But yeah, so both of those things I think prepared me pretty well for jumping into the OpenRewrite visitor pattern.
Yeah.
Uh,
Yeah, it makes a lot of sense what you're saying, because once you understand the data model of how an LST is put together, then that translates very directly to what the visit methods are in the corresponding visitor. And
Yeah.
conversely, if you did not understand the data model, you would not even know where to begin with, like, what method do I override from Java visitor? I don't know what a compilation unit is. I just type code in its textual representation.
Yep.
Yeah, that jives with my experience of teaching people to use OpenRewrite, and really having to start with the data model, start with the LST, point out how it is structured and recursive. So that makes a lot of sense to me. Yeah. So you've made a lot of contributions to OpenRewrite in Groovy, particularly in the Groovy and Gradle spaces. Were there any that were particularly challenging that you worked on?
I think it comes back to that dependency update one, because we had to make some changes to the LST model itself to support capturing the more of the Gradle model aspects.
Yeah, that was challenging, because Gradle was not something like Maven. You can figure out what dependency resolution is going to do totally statically, just looking at the POMs and their parents. But Gradle, it's all code, so I could write a Gradle plugin that does anything imaginable with dependencies, right? Flip a coin, add a dependency, or not, depending on. So you can't look at just the build Gradle files and statically know exactly what dependencies are going to be resolved. So yeah, I remember that, us all getting through that hoop together of getting the dependency model out of Gradle and into the LST.
And it was even getting multiple aspects of that model out. There's project dependencies, there's project plugin repositories, there's settings repositories. Like, there's so many different ways that you can set a repo that it's just like, okay, what's my effective model here?
Yeah, for sure. Very cool. So I understand that you've been tooling around a little bit with a long cherished thing that we've wanted to implement, and many of our users have wanted, and that is support for Gradle Kotlin scripts, which has kind of all of the challenges of Gradle Groovy scripts, and then some more, because Gradle goes through a bunch of code generation in order to turn a build.gradle.kts file into something the Kotlin parser or the Kotlin compiler can work with, providing type safe accessors for all of the DSLs you use that come out of the plugins block and the like. So I've maybe personally been a little bit daunted by that task, and almost seem to find some more urgent and more manageable problem to work on instead. But you started picking up my slack there. How's that been going?
It's going. The Gradle Kotlin bits are kind of interesting. For some people, they might not realize it, but Kotlin scripts actually usually go through two phases of execution, where your plugins block is actually interpreted.
Yep.
and then the rest of it is actually executed as compiled code.
Oh,
These are
really?
super-
That's how it works with Gradle Kotlin scripts. That's interesting. See, I didn't realize it. I knew plugins was processed separately, and then because it sets up the class path for the rest of the file. So
Yeah.
the rest of the file can't be interpreted without the plugins block. But I didn't know it was actually handled like in a different mode. It's not pre-compiled; it's interpreted.
They interpret that so that you can get all the dependency declarations ahead of time.
Right.
And then they just eject it from the intermediate model and then compile the rest and say, run it.
With a code generation step, right? Because you have to, if you're using accessors, type safe accessors, or for like things that the plugins add, those don't exist in the current project scope until those dependencies have been resolved and that code generated.
Yeah. You even have the type safe accessors from like the versions.toml file as well to contend with that just kind of come out of nowhere.
Yeah. Another way of declaring dependency versions in Gradle.
Yeah. So that work seems to be getting close. The Kotlin parser does a decent job at parsing it already, but it's just missing all the type attribution.
Yeah, which is useful. You get to have the type attribution.
So that's really the last mile there is like, how do you get that type attribution that's generated from Gradle into the Kotlin compiler? And then from there,
are you interested in having collaborators on this project? Like, do you want to? Yeah, cool. So you want to? What do you have a link to the repo you're working out of? Because this isn't Shannon's personal space. It hasn't been added to OpenRewrite itself yet. Although if he gets it working, we'd be more than happy to bring it into OpenRewrite. Yeah, let's get a link in there so anyone can see and maybe help out with your work in progress.
Yeah, for sure. I can post a link for that out here. It is very much a work in progress.
Yeah.
No. Let's see. I'll have to share it to you, Sam.
Yeah, that's fine.
There's the link for it.
You send it in Slack?
No, it's private chat here.
Oh, yeah, that makes sense.
Yeah, I got it.
Excellent. Thanks, Tim. So yeah, anyone who's interested, who's been like, man, I wish we could use these Gradle dependency management recipes, but we adopted Gradle Kotlin script. Maybe help Shannon out on this, and we can realize that long held dream of Gradle build users who like static types everywhere. Right on, man. Yeah, my kind of like technical thing that I'm still wondering about for this is like how, like, I can understand how we could capture the generated the stuff that Gradle generates like at build time, like when when we parse the LSTs, that we could get those, because there's source files on disk somewhere that have those type safe accessors in them, and we could go grab those and feed them into the parser. I wonder how we'll be able to handle like mid recipe when you need to like generate a snippet of code in Gradle Kotlin script. In other languages, you just new up a parser, right? And even like Java template is doing that behind the hood. But in this context, if we're relying on something external to do code generation that's necessary for type attribution, I wonder how we'll navigate that.
Yeah, I mean, even for the Gradle Groovy DSL. I mean, today, like, we're
so it's a little awkward, right? We kind of have a shim, which mostly works for the common stuff, but wouldn't be great for like if you were trying to modify stuff provided by plugins.
Yeah, for sure. I'm not sure how that's going to work because of the need to reach into the Gradle distribution as well as grab that generated accessor code as well. So I don't know how that's going to pan out. It's still kind of an open question in my head.
Right. So we need to get like the appropriate like Gradle API and everything. Yeah. All right. Yeah. So some interesting technical challenges to surmount there. So I don't know if anyone from Gradle is watching. Feel free to take that code that Gradle uses to generate those type safe accessors and put that in a nice little library that we can reference. That would be very helpful. Right on. So you mentioned earlier that you work at Shelter, and that part of how you found out about OpenRewrite was at Moderne. Co-founder Jonathan had worked at Shelter at one point. I've now met quite a few engineers from Shelter, including yourself, who are extremely good at it, like that have real technical depth in a variety of fields. Is there something that Shelter Insurance does right to help nurture great engineering talent?
Yeah. So this is going to sound a little funny because usually when a company says this, it starts to send off red flags. But when I joined at Shelter,
And you joined 13 years ago, is that right?
it's 11 this year.
11 years ago, got it.
Yeah. I was told really early on that Shelter's a family. And at first, like normal technologists, we kind of take that as a wait a second. That usually doesn't mean what an organization says it means. But what I've found is that Shelter really stands by that. And what I mean is that like your own personal siblings, they'll jump in and help you when you're having a problem. They really push you to be your best self, do your very best, and when you don't know an answer, it's okay to say I don't know. And then we'll work together to find that answer or find you someone who does know that answer. And really work to help level up a person as an individual. Because, as an individual, you can go far and fast. Or sorry, you can go fast, but as a group or a team, you can go really far.
If you want to go fast, go alone. If you want to go far, go together.
Exactly.
Yeah. Well, right on. That's great. Yeah. In addition to you and Jonathan, there's also Kevin, the head of our platform team, who makes the Moderne SaaS, as well as the Moderne CLI, which has a background at Shelter. So I've known at this point, I've known a lot of great engineers who got their start there, who are still there. Yeah, right on, man. So you're here, and unlike normal times when I would just crudely ignore you, you can ask me directly or make a wish. Like if OpenRewrite did one additional thing that it doesn't do right now, or one problem was fixed, like if I could wave my magic wand and make OpenRewrite better or more capable in some way, how would you have me wave that wand?
The one that comes to mind is more parsers.
Yeah, absolutely.
There's a lot of parsers today that deal with different languages, but
for sure,
even as a financial services organization, there's still languages out there that we have that don't have parsers yet.
For sure.
Sometimes you have to use text replacements, and it works. But
if text replacements were good enough, we wouldn't have OpenRewrite at all, because we'd all be dissatisfied with our regexes.
Yeah.
So we're obviously working on C# right now, and Canute is heading up that effort. What other kind of languages are on your list? You got the typical, Python and JavaScript and the like.
Yep. TSX is kind of the one that jumps to mind, both for like React code, where it's kind of an intermixed TypeScript and HTML language compound. Right. That's the biggest one that jumps to mind, at least at the forefront. But there's others that I'm sure you know about.
Yeah, fair enough. So at this point, you are, an expert recipe author. You've probably tried just about every recipe authoring pattern that exists. Do you have a favorite tip or trick or technique you find yourself going back to? Something that from experience that other recipe authors might not know that they would benefit from?
Yeah. The one thing that I lean on personally is it comes from the Unix idea of do one thing and do it well.
Yeah.
With recipes, like if you focus in on I want this recipe to do this exact thing. You can then take multiple recipes and compose them together, or their visitors and compose them together to get higher and higher order compositional elements.
Yeah.
And that's, I think, where that compositional or that function composition really starts to shine.
Yeah.
Especially when you get into, like declarative recipes or,
for sure,
things like that.
Yeah, fair enough. And I think that aligns a lot with something I found myself doing more and more often with recipe authoring, is particularly the more complex a particular recipe or a particular visitor gets, the more I'm finding myself benefiting from implementing it not with a single visitor, but with many visitors, one per each individual problem, as part of creating that recipe. And I've started to see visitors kind of like a super powerful for loop, right? It's like it's less like I don't know, the whole recipe, and more like just a control flow structure, right?
Yeah.
It's like in the same way that when you're working with complex or multidimensional data, you might nest recursion or nest loops, nest control flow structures in your code. I find myself starting to nest visitors. And then that lets you, have like the outer visitor in your recipe kind of responsible for validating just, is this a case that I'm interested in refactoring? And then you have several smaller visitors within that actually affect each part of that refactoring operation. That's actually something I spoke to a little bit, I think, in the previous community office hours. So if you're finding yourself having gotten to the point of maybe being an intermediate or a journeyman recipe author, where you're like, okay, I know what the LST is like, and I'm pretty familiar with the basics of a recipe and a visitor, but I now have this problem that I'm struggling to actually get a working recipe or for whatever reason. I would suggest checking that out as kind of thinking of visitors more like control flow and less like I don't know, a single God class, less like the entire program or the entire recipe itself. I found it more complex scenarios became more manageable for me.
Yeah, I think one aspect of that you have to watch out for, though, is just like with nested for loops, you can sometimes hit a performance bottleneck too.
Oh, for sure.
So.
For sure, yeah. Decomposing into multiple recipes. I would say, like, often I have a challenge of like one part of the tree has the information I need, and I want to act on that information in another part of the tree. And there's a couple ways you could handle that. One is like cursor messaging, right? The thing that's visiting the sub element puts a message in the cursor on the element where the change actually needs to be made. And similarly, putting a message in the execution context or a transient field, or just a field on the visitor. All of these are ways you could get information from one point in the visitor to another point in the visitor. But I find cursor messaging can make for difficult to read recipes, because particularly for it to make sense, you have to have that full structure of the LST in your head. So if you're thinking about this visit method is like a parent of this other visit method. So, after I call super.visit up here, this child visit method is going to populate the cursor, as a side effect of running. And then I just know that side effect will have taken place, and I'm able to access that data. And I think even as an experienced recipe author, that can make these harder to read and understand, particularly as a beginner. It's just like, what the heck is going on here, compared to like decomposing into like totally separate visitors. It's like very clear, this is the like go find the sub element that I care about visitor, and it does exactly what it says, no side effects. But yeah, absolutely, as you say, traversing the tree is not free. A CPU's got to churn through all those elements and make all those function calls. So there's potentially a performance or readability trade-off there, depending on what design pattern you use.
Yeah, the cursor messaging, like when you mentioned that, like the recipe that comes top of mind is the HTTP security DSL for Spring.
Yeah.
That takes a second to remember.
So this is a recipe in Rewrite Spring you're talking about? I'm not sure I remember this recipe off the top of my head, but it's particularly complex usage of cursor messaging.
Yeah. It's trying to collapse all the .and methods out of the HTTP security flow,
Mm-hmm.
and instead transform those to a singular Lambda call chain.
Right.
It's kind of hairy.
Yeah, that's a gnarly one to get right, and we see that with you look at how many iterations that has gone through by now. All of them just from feedback that it maybe handles a lot of cases well, but kind of in some cases gives up and points a link to the doc. Go do it by hand. It's a tough one.
Yeah. But if it's definitely always better for a recipe to say, "Hey, I can't handle this. You've got to do something manually here," than to YOLO it and make a change, which might not be right.
Yeah.
Right on. So speaking of waving magic wands, I already don't actually have a magic wand for the Open Rewrite project where I could make anything instantly come to fruition. But I even less have a magic wand that could affect anyone else. So are there any libraries in common use, libraries or platforms that you're familiar with? You're like, man, I wish there was a recipe for this.
Oh. I think a lot of the libraries that I use on a typical basis have recipe libraries available.
That's great.
But with that said, there's features in them that are missing.
Absolutely.
One that I recently came up against was OAuth 2 transformations in Rewrite Spring. So I was like, okay, well, write a quick recipe, poof, that's gone. Not a big deal. Obviously want to get that contributed to OpenRewrite, but that way more people can get started.
Yeah. So speaking of, we had Jay Olvera in the chat ask, I want to start contributing to OpenRewrite. How should I get started? Do you have any tips about that, Shannon?
I think the best way to get started is coming at it with a problem, because then you have a context to solve toward. From there, like the OpenRewrite Slack is a great place to ask for questions. The Rewrite Test Harness is great to get started for doing the transformation itself. You come up with a minimum example, like, hey, here's what it should look before, here's what it needs to look after. And then from there, it's really just starting to write the recipe guts itself.
Yeah, absolutely. I'm just going to grab an invite link to our open source community Slack, which I've put in the chat there. So yeah, if you're looking to get started with OpenRewrite, I recommend, Shannon's advice is excellent. Also check out our documentation, which I've linked to docs.openrewrite.org, and join us in the community Slack, and you can directly ask questions of experienced recipe and parser authors like Tim, Shannon, and myself. And we're happy to try and help out new and prospective contributors. Speaking of recipe libraries, you've also made several contributions to Rewrite Launch Darkly. Can you tell us a little bit about the maybe challenges with using feature flags, which have motivated you to make contributions in that area?
Yeah, I think there's kind of two parts there. Like a lot of organizations using feature flags can help dark launch or gate off pieces of functionality until you're ready for it. So there's advantages there, but at the same time, it's like the same problems that you run into with, as like a financial services industry, trying to keep up with the open source industry. Like open source communities are running a mile a minute. Keeping up as a enterprise organization is hard, just even from a dependency standpoint.
Oh, for sure.
Even with automation, but then you layer in types are moving from one package to another. The APIs are changing slightly or subtly, all for good reasons, and good with good justification behind them. But
sure,
find and replace scales only so far.
Absolutely.
And that's where I really think like recipe development comes in. So like for Launch Darkly in particular, like finding out like where all are we using feature flags that we've long since forgotten about.
Right.
And then furthermore using the like remove Boolean variation to then like just go get rid of it. It's dead anyway. Make it gone.
Yeah, totally.
Yeah, that was a fun one to help write and figure out that we already have all the components. We just needed to group them together. And, now it's there.
Nice. When you're talking about having all the components and just needing to group them together, what do you mean? Like in terms of features in OpenRewrite, or?
So if you look at the implementation for the recipe that removes that Boolean variation, it is very sparse. It calls out to a recipe that we already had as part of our static analysis recipes, where it picks the left or the right hand side of a Boolean if the conditional is guaranteed to be true or false. So then it was just a case of finding the feature flag and setting that to true or false, and then can just rely on the things we already had.
Nice. So Shannon, are you guys at Shelter already using those Launch Darkly recipes on the regular to get rid of old feature flags?
In part, yeah. It definitely a lot nicer to get rid of them that way than having to go manually modify code bases, especially if that feature flag might be used across multiple applications in a unified system.
Totally.
And also
huge.
Oh, go ahead, Tim. Sorry.
And also in terms of time, like you've already long ran your experiment. You know which site you want to enable or disable, but 3 months after, you still need to clean it up, and it's nice to be able to automate that part.
Yeah, I feel like feature flags provide a good example of how even if you do everything right in software development and make no mistakes whatsoever, you still create problems for yourself later. You still create work for yourself later that you have to then come and clean up and redress at some point. And I think that that points to why something like Moderne and OpenRewrite are so necessary or so useful, because whenever you're like using a feature flag, it's like, well, at some point in the future, this becomes a problem that I have to clean up, right? It's giving me something right now and it's a problem later. And there's so many things like that, like just taking a dependency on an open source library. And I think that if you can automate away the tedium, the very predictable tedium that comes from making some of these choices, then you just have more time, effort, and energy to spend on the challenging parts and on the parts that are really beneficial, rather than the cleanup and supply chain management.
Yeah, for sure.
Right on. Yeah, I feel like that's about all the subjects that I had kind of prepared to talk about. Shannon, is there anything cool that I should have asked you that I missed?
Oh man, that's always a hard one to answer. There's just a lot going on in even the OpenRewrite organization.
Totally.
I guess there's still like one curiosity that I've been keeping an eye on from you.
Sure.
Is that the whole potential elimination of cycles entirely.
Yeah.
And in particular, like the curiosity zone for me is like that intersection of no cycles and scanning recipes.
Sure.
Because that's always a hard boundary for cycles in particular.
It is.
One scanning recipe might generate a class and the other one needs to see it, but that just inherently means a cycle is needed of some form.
Yeah. Yeah. So to provide a little bit of context here, Shannon is referring to a kind of key implementation detail of the recipe execution lifecycle, which is that right now, when your recipes are run in a loop, right? That you'll run a recipe and it'll get to see all of the source files, all of the LSTs in the project, and make changes to them or not. And then we start over and we run the recipe through all of the LSTs again to kind of give it a chance to stabilize, right? To make sure that if recipe A made a change to a file that recipe B is going to be interested in, that recipe B gets to see A's changes, even if regardless of the order that those two recipes were in the list. And we've thought about, I've actually personally tried to eliminate this concept before, because as you can imagine, if your recipes are traversing all of the LSTs multiple times, well, that more or less multiplies how long is spent on recipe execution. There's a very real performance cost to doing that. Um, and yeah, one reason my attempt to remove the concept of cycles was stymied was, uh, well, it turned out to be like several little things. It was not quite death by 1,000 cuts. It was maybe death by 5 to 10 cuts. But one of them was definitely, yeah, this problem that you actually kind of still, well, yeah, the problem of a scanning recipe gets to scan through all of the sources once, and then it gets to optionally generate new files. So like a pin to text file, for example, could create a file if it wasn't there, and append to it if it was already there. And then there's the edit phase that all recipes can participate in, not just scanning recipes. And you have this maybe back and forth between a recipe, generating a new source, and other recipes wanting to know that source is there. Um, yeah, I feel like now maybe I'm just kind of rambling on the subject, which might reflect that I haven't figured out how to perfectly solve that problem, or I would have, or I would have done it and gotten rid of cycles already.
Yeah, it's a hard problem.
I recall we had a really long lead up to very nearly removing them, and then a very swift reversal when we figured out that turns out our testing harness didn't fully cover all the cases that it should have.
Yeah.
Oh.
Yeah, and there's still a gap, even with cycles. There's a problem that I've been thinking about how to fix for a while, where if you have two scanning recipes that are both interested in the same file, like imagine if you were running create file and then like append text to file in sequence after each other. Well, both of those have to be scanning recipes. And I mean, in this particular example, you could just use append since it can handle the create on your own. But it's not crazy that someone would be like, let's try creating it and then append to it. Like, that should work, right? Like, that's a very sane and normal thing to do. But since both of those are scanning recipes, they're both going to go through the scanning phase. Both recipe is independently going to register that this file does not exist yet. And both of them are going to decide, I need to create this file. And so then in the stream of LSTs, that is the product of running these recipes together, you'll have two separate entries for the same file, both of which will be written to disk in the same place, and you'll get like a last wins sort of situation. So what I've thought about for solving that problem is that whenever a new source is produced by the generate method of a scanning recipe, all the other scanning recipes, at least those that haven't run yet, well, none of them will have run yet, but all the scanning recipes would then get to have their scanner applied to it and notice that the new source had come up. So that was my idea for that. I just haven't actually implemented it and found out what problems might might be caused by this change yet.
Yeah, for sure. There's some interesting corner cases in that realm.
There absolutely are. And we get to one of these kind of inherent design tensions that are in OpenRewrite of like, we have trying to balance, well, performance and correctness, right? Because you could just run the recipes in a loop forever until the output was stabilized. And you're like, okay, all that we know for sure, all the recipes have had a chance to see and respond to every every change to every source file. But that's bad for performance, right? That takes a long time and is very intensive, and most of the time isn't particularly necessary, right? Most of the time, recipes should make all of their changes on the first pass and be done. And the same thing with like scanning, generate, edit by like kind of restricting the recipe execution lifecycle to that particular shape, we get a huge amount of performance benefit out of that. Since it really, particularly if you have a very large repository where LSTs are serialized to disk, when running through the Moderne platform or the CLI, it limits the number of serializations you have to make. It limits the amount of stuff that has to be loaded in memory at once. It makes possible the processing of very large projects, but it is much more restrictive than the API we had in Rewrite 7, where you could just access the list of all of the LSTs, which would be available in memory, and change it any which way you wanted, which was very flexible, very easy to use, and impossible to make work if without actually having every LST fully loaded in memory all at once.
Yeah.
So what do you think? Is there anything missing from the recipe execution lifecycle? I mean, we've talked about some, maybe we could tune the performance by removing cycles, that maybe we could kind of fix some of the edge cases around how scanning recipes and file creations interact with each other. Is there anything else in that design space? Or if we knocked out those kind of problems or potential areas for improvement, would we be done with recipe scheduler? I mean, aside from adding support for new languages like C# and the like.
Not sure. I think really, I think the biggest crux right now is the scanning recipes behavior when you have multiple that are all trying to do something with a single top level LST element.
Yeah, for sure.
Beyond that, though, like normal tree visitors and their edit phase, like that's pretty consistent and just kind of works all the time.
Yeah.
Even like multiple scans of scanning recipes, like that works accurately.
Yeah.
It's just this weird combination of more than one scanning recipe. That's the only thing that I can really think of from a recipe execution standpoint, at least.
Mm-hmm.
The only oh crap, I made 2 again.
Yeah.
Whoops. Let's not do that.
Yeah, this kind of reminds me of an area of our API that I have kind of just on the side been thinking about. How do I improve this thing? And I wonder if you have any thoughts here. And that is around when you were trying to compose scanning recipes together, or for example, use a scanning recipe from within another recipe. Right now, you have to, if you're going to use a scanning recipe in your recipe, you have to take responsibility for making sure that scanning recipe gets to have its scanning phase and its generate phase before you use it, which is harder than a regular recipe where you can just be like new recipe.getVisitor and there's your visitor and you can use it in line with no other stuff. Yeah. I wonder if there's a way we could make it easier to compose scanning recipes together.
I think there probably is. Even another slight extension from that is when you combine 2 scanning recipes together, you then have to manage the accumulator as well.
Yeah.
And it feels like that could just be carried along with the context. Sometimes
maybe it could.
Everything together.
Yeah, but I was wondering if we could make it so that you have I don't know, an injectable field perhaps. You just declare that I have a field of type this scanning recipe and I annotate it with inject, and maybe we could notice that reflectively and just manage its accumulator state for you and just hand it to you somehow.
Maybe.
Well, yeah. If you or anyone else has ideas about how scanning recipes could be made easier to compose together, let me know, because it's something I've been thinking about. Because I found myself writing code that composes scanning recipes together into one scanning recipe enough times now that I should automate this pattern so I don't have to keep doing it. It's just starting to happen. So
yeah.
All right. Well, I think this has been a great conversation. Tim, is there anything else you want to add or ask before we wish Shannon thank him for being here and wish him good day?
Nothing I need to add. No.
All right. Well, hey, Shannon, Thanks a lot for being here. This is an interesting conversation, and I hope that there are many potential recipe authors and Open Rewrite contributors in the audience who are going to follow your path and make this a really great and really powerful framework for everybody.
Yeah, for sure. Thanks for having me, guys.
Yeah, thanks for joining
Yes,
us,
thanks a
Shannon.
lot. And then very briefly, next week we got a new edition, and next week we're going to focus on contributing to open source software through the Moderne platform, using the open rewrite recipes that we already know and love, and applying them to projects that we similarly want to help along. So be sure to tune in, and we'll see you next week.
Thanks a lot, everyone. See you then.
Thanks a lot. Cheers.